We are going to discuss about the part 2 of polynomial. In this section, we will be discussing about a remainder theorem, factorization, and some part of identity. I would like to request you one thing. You know, after this program is over, after this presentation is over, kindly like this thing as well as subscribe. This subscription is free of cost. You don't have to pay anything. Nobody will come to say you have subscribed, so please pay me so much of money. Nothing. Why this subscription is necessary? Because it helps me to get a better idea about the presentation that I have done. So more people subscribe, that means I've done a good job. So in this case, let us talk about what is known as remainder theorem. Remainder theorem. I will just go back a little bit and remind you that we have talked about a polynomial, a standard polynomial, which represents, say, of n order. So it should be an minus 1 into xn minus 1, and it will continue like that and go up to a to the power a0 to the power x to the power 0. So this is a polynomial and this is in its standard form. What is the meaning of standard form? Because as you go down, you will find its degree is reducing. Okay, so now instead of writing the whole thing over and over again, we have said that we will represent it as px. It's not necessary that I have to write px. I can also write asx, tx, anything. But this shows it's a function or is a polynomial of n. Another thing I have also emphasized, that it is very important to notice this coefficient. What is this coefficient? As I have said, this modifies the value of n. This is the variable. These coefficients are not variable. You will come across coefficient in many parts of physics. Say, for example, coefficient of friction, you will find as coefficient of friction, coefficient of linear expansion, coefficient of friction. In your friction classes, coefficient of linear expansion, volume expansion, linear expansion, volume expansion, area expansion, etc. So basically this coefficient changes the actual value of this particular term. Okay, so this is very important you do it. Second thing you must see and find out from here, that there is no minus on the standard form. Then in some polynomial, where does this minus come from? The minus comes from this coefficient. So here if it is a minus, then it will be minus an minus 1. So that will be. Let us take a polynomial 3x square plus x plus 1. Okay. Now this is its degree is what? 2. That means it is a quadratic. And this is going on a standard way. So this is 1, even though it is not, but this is 1, and here 1 means this is x to the power 0. This we have said. So now let me go back to now I have refreshed your memory about the things which I have covered in the part 1 of the video. Now I will go into the remainder theorem. What is the advantage and disadvantage of a remainder theorem? See, this remainder theorem and factor theorem, they come together. First is the remainder. If a polynomial qualifies through the remainder theorem, I will use that word, then only factor theorem takes over. What is this thing we will discuss? Let us take 15 and let us divide it by 4. So how you want, it's very easy, right? 3 into 4 is 12, and so this is 3. Okay, in the term, this would be dividend, this should be divisor, divisor, this should be quotient, and this is, we call it remainder. Okay, you are all familiar, class 4, you have done it. So there is nothing in this thing. Two things you must see from here, which is important for us, that this 3 will always be less than 4. If it is not, say this 3 is more, then if it is 4, then this 4 will go again once. So the remainder is always lower than divisor. In case of polynomial, we will call this dividend as px, we call this divisor as gx, and we call this quotient, let us say qx, and let us say this remainder as, you can say, rx, but this rx is not possible. Why? Because this generally what we were talking about today, this divisor gx will be a linear polynomial. Linear polynomial, right? Linear polynomial. So if it is linear polynomial, then its x power will be x to the power 1. So if it is lower than that, then this power has to be x to the power 0. If it is x put to the power 0, then that is equal to 1. That means Rx will always be a constant. Do you agree with this? I think there is nothing to disagree. You must be agreeing with this one. And then we will now, how will I represent 15? Very easy to represent 15 will be like, say 15 will be equal to, 15 will equal to 3 into 4, 12 plus remainder 3, right? This is the way I will represent 15 here. This is the way. Okay, in terms of polynomial, how do I write it? I will write 15 as px, then this is 3, that will be, I am dividing was with 4, so this will be gx, this will be qx, you can interchange it, and this will be the remainder. So this we all understand that. Okay, so now what does that remainder theorem says? Remainder theorem is very specific. It says if we have a polynomial px, right, and what is this should be its order? It should be greater than equal to 1. That means either this will be a linear or polynomial or more than that. If this linear polynomial is being divided by x minus a, linear or any other of higher order, equal to means higher order than that, is being divided by another linear polynomial, this is one linear polynomial, mere, and let a is any real number, any real number. What does it mean? What does it mean? A can be 1, a can be 0, a can be root 2, a can be anything. If I now substitute this a in px, what is the meaning of substitute pa in px? Then whatever be this thing, say for example, if I take 3x square plus x plus 1 as a polynomial px, then I put a everywhere. That means I put this is a3 into a square plus a plus 1. Okay, so if I put p equal to a, then it should give me the remainder. This is as simple as it is. Find out what would be the value of a and then you will do it. How would you get the value of a? This will be given. The a would be 1 or 2 and you put it there, then you will get a remainder. If you get a remainder, then this will not be able to factor. There will be no factorization. Do you understand the connections? Now is the connection clear? There will be no factorization on this. Let us see certain examples. Let us say I have a polynomial 4x cube plus 3x square minus 4x plus k. Okay, this is my px, and it is being said that x minus 1 is a factor. It is given. What I have to do? I have to find the value of x. x का value निकालो, find out the value of x. क्या करना है? It's already a factor. That means if I put here x minus 1 is equal to 0, so x equal to 1. So if I put in p1 here, it should be equal to 0. That's a basic premise. From that I will find out the value of k. Okay, so let us do it. 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k, that would be equal to 0. Given, it's given, then it will be 0. Okay, so what it will be? 3 into 4, this will be cancelled, so k will be minus 3. So this is the way how you utilize your remainder equations. So this, once we have gone through this one, say for example another example I will go through that will clear, I think, everybody's doubt. Say for example, find out whether 2t plus 1 is a factor of polynomial 4t cube plus 4t square minus t minus 1. Okay, so what is this? This is my px, or no, this is t, so I will put t here, pt. This is my gt. So this I have to find. Is a factor of this, right? Or I can write it this one. Find out whether et is a multiple of 2t plus 1. So you understand this multiple and you understand this factor. Say for example in this thing, 12 is equal to 4 into 12 is equal to 2 into 2 into 3, right? So these 2's are all factors, right, of 12. And 12 is multiple of 2, multiple of this 2, and the multiple of 3. So the bigger one is a multiple and the smaller ones are factor. So if I have to do this one, what I will do? One at a time. First, I will take this one. So I will take gx, gt, 2t plus 1 equal to 0. So I will find t equal to minus 1 upon half. So I will now find whether p minus half, right? So if I put p minus half, what will be? 4 into minus half by cube plus 4 into minus half by square, right? 4 into t square minus half minus 1. Whatever, both, it has become too big a 1. Okay, let's take care of this. So this is cube, so minus will remain. Minus 4 into half into half into half, right? We will do it later. Plus square, so it will become plus 4 into half, right? So minus half will remain 1, minus 1. This and this will cancel, right? This one and this one become this. This will also become 1. Then you will find what does it become now? This will be, all this is cancelled. This will be minus half. This will be minus half, right? And I think this is minus 1. So this should be minus 2. Right? So it's not a factor of this. Am I clear on these issues? So this is how you utilize this polynomial theorem. Okay, now let us go a little bit on. I will stop by finishing up factor theorem, because I think student will be more attentive during this period, about 20 minutes or 15 minutes. So what is a factor theorem? Factor theorem says that if I have a polynomial which is nomial, which is ax square definitely, bx plus c, this is my polynomial. इसका factor क्या होगा? Let it has a factor px plus q into q के बाद क्या होगा? qr rx plus s. Okay, because remember, since this is a quadratic polynomial, there can be only two roots. So it can be only two factors, 1 and 2. अगर ये quadratic होता तो 3 फैक्टर निकलता. ये आपको immediately आपको याद होना चाहिए. So इसको मल्टीप्लाई करो, पहले वाले से करो. It will be pr into x square, pr plus rq into x plus s से मल्टीप्लाई करो, ps into x plus sq. ठीक है, ऐड कर लो, pr x square plus x plus rq plus ps plus sq. ठीक है, अभी कंपेयर करते हैं इनमें से. Always you can compare if two things are equal. They are equal because I have taken them equal. Unequal हो ही नहीं सकता. तो इसमें से क्या होगा? A होगा pr, ठीक है, C होगा sq. What is the multiplication of A into C? pr into sq. ठीक है, इधर में देखो, इधर में यही दोनों है, ps and rq. So इधर में जो प्रोडक्ट है, this product, this addition, इसका ही प्रोडक्ट होगा ये यहाँ पे. कैसे होगा? अगर हम किसी को एक को ले लेते हैं तो उसमें से मान लो एक आया 6x square. Let us take an example. 6x square 17x plus 5. ठीक है, इसका a क्या होगा? 6. a equal to 6. b क्या होगा? c क्या होगा? 5. दोनों प्रोडक्ट 30. राइट? अब इसको मैं ऐसा स्प्लिट करना चाहिए ताकि ये 30 हो. दैट वुड बी 15 into 2. तो ये कैसे होगा? कैसे होगा इसको? इसको होगा 6x स्क्वायर, ये कोई चेंज नहीं है, प्लस ये होगा 15 प्लस 2. सो 15x प्लस 2x और प्लस 5 लास्ट में. ठीक है, क्योंकि 5 था यहाँ पे सी में, ये 5 है, वही 5 यहाँ पे गया. तो यहां से हम कितना लें? 3x ले लें. ठीक है, सो 2x आ जाएगा यहाँ पे, प्लस 5x गया इधर में, प्लस 1 लेंगे 2x प्लस 5. Many student does not take 1 here. This 1 is necessary. You multiplying by 1. Otherwise ये दूसरा फैक्टर नहीं बनेगा. ये 3x प्लस 1 नहीं बनेगा अगर आप इधर में कुछ ना लो. So ये please remember this. So this is your 2 factors. So this is the way. This is called splitting in the middle. Splitting मतलब क्या है? तोड़ना. बट तोड़ना ऐसा है, ऐसा टुकड़ा बनना चाहिए जैसे इन दोनों का प्रोडक्ट AC हो. कोई भी टुकड़ा से नहीं चलेगा. तो this method that I have told you, this you will find in many videos that this has been explained, but this is not covered in the CBSE exam, CBSE book. This is not covered. But you know, you will be given multiple choice questions, MCQs, multiple choice questions. So their speed is required. So if you can show this one, they will just say, are these the factor of this? This is what, find out what is his reminder. If you can do it fast, you are gaining on time. Okay, this is a method which is used, and you must remember this. Remember, polynomial is also a chapter in class 10. So understand polynomial very, very carefully and very, very nicely, so that you do not have any problem in class 10. Okay, thank you.